Yes, welcome. This is the hands-on demo video for the presentation I'm giving about Azure Container Services. You can find all the source code on this URL. The presentation itself is in this folder, and this is also where you can find the sources I'm using in this demo. This is the presentation itself. Yeah. So I'm going to a terminal. I'm making a demo3 folder. I do a git clone of this URL. So first I talk a little bit about container technology and about Docker. And when you go to the Docker demo, I show this Docker file. So it's a very simple file. I do a Docker build -t test demo 1.0. It's in this folder. So now it's complaining it has no Docker environment. Docker machine ls. So I see I have one environment running. It's this one. I just need to load the shell environments for this one. So I do eval and demo. So now I can run Docker commands. This is my local repository. There is also already some images in it. But like I said, for this demo, I'm going to create this thing called test demo 1.0. And the Docker file is in this folder. You see it's created. Now when I do a Docker images, I can see I have created this image. Docker run. If I like to run this, I just do this. And you see it's just doing very simple stuff, which is in this script. So this is of course not very interesting because usually you would have some kind of a web app or something like that. So you can also create Spring Boot app. So this is a Java application which is being built with Gradle. And as you can see, if you guys know Spring Boot, it's a very lightweight form of running an image. So when I do a Gradle build, it will generate a jar file, and it's using the build.gradle file, like Maven uses a POM. Gradle uses the build.gradle file. And the result of this is that you have in your build.lib directory, you would have a jar file. Yeah? So if you like to run this just in your shell, you would do something like java jar build lib, and then you would run this thing. And you will see it spins up a mini container, which is defined in the build.gradle. Usually that would be something like Jetty or Tomcat. So now when I go to localhost.8080, I will see greetings from Spring Boot. It's very simple. So if I want to wrap this in a container, I would say I would create a Docker file. Again, I use Alpine. Alpine is a very lightweight Linux operating system. It's only about 5 megabytes, but when you put Java on it, it grows to 100 megabytes or so. I expose port 8080. Then I'm copying my jar file, which I just used, into the etc folder of this image. And then I say I run the Java command I just show you. So if I'm going to build this, I do docker build -t tagging Java demo Spring Boot 1.0. So it's already built. Docker images, you see, it's available. So now when I do a docker run -d, I'm putting it in the background. I'm exposing port 8080 also on the outside, and I'm running this image. So when I do this, I see that my image is running. If I want to look in the log file of this, docker logs, you see it's booted up. Yep. And now when I run it, I have the same result, but now it's in a Docker container. So the whole thing of Docker being able to grab this image, ship it to somewhere I would like to ship it to, and then run it into some kind of production environment, this is already possible with this technology. So I'm going to stop everything now. Docker stop. I'll clean it also up. Yes. So in reality, you would of course have an application which is not a standalone application. It would be an application which talks to a database or a service, or in my case, I have a demo for a Java application which uses Redis as a caching mechanism. So in this case, I have a Java application which is being built by Maven. So you see here the POM file, and in the POM file I have a special plugin which creates for me the Docker image. Docker. So here I say, okay, this is the name I want to give it my Docker image, and this is the metadata I showed you in the Docker file, and the main image is based, or the image is based on this main image which I created before, which is basically a CentOS image which runs Wildfly on top of it. So it's much more heavyweight. So if you look at here, you see the Wildfly image is already in my local repository, and it's 602 megabytes. In comparison, if you look to the Spring Boot app, it's only like 135 megabytes. So something worth considering later on. If I'm creating Maven clean build and I do -d version and I'm calling it 2.0. Oh. It's not clean build, of course. I was confused because I just used Gradle. It's clean install in this case. So it's created it. Then I'm going to call the Docker plugin. So it's Maven Docker plugin, and this is called build. I'm giving the version is 2.0. Going to build it. Images. So you see it has built it for me, this image. I need to check up on something. Source Java. Okay, this is what I do. So like I told you before, in reality you would have a Docker image which will talk to other images, and in this case you can use Docker Compose to make those images talk to each other. So in this case what we would have here, is one image I just created, in the Docker Compose file, and you see it's depending on Redis, and I'm running Redis on port 6379. And if I want to have this up and running, I just need to do Docker Compose up. So you see it's booted, you see a cool Redis logo coming up, then my application is coming up. You see here the context, which I defined in some JBoss XML file. So if I now do logos and I go to the context, you see this is my web app, and you see this one is in the Redis counter, and this is just done per request. Have a look at the source code. It's a very simple demo. But if I'm now starting up another browser and I'm going to this, you see it starts here with 1. And of course, later on when you do some kind of load balance test, you can see the Docker host name and the URL you're using. So, that was a small demo about Docker Compose. So let's see what I'm going to do more. Okay, Spring Boot up. I've talked about Java Redis up, running Docker. Okay, so let's see how we can run this application on Jenkins. And usually you would have like a Jenkins instance. Chris, and you would deploy on a third-party machine. But for this demo, I'm just deploying my Docker image on this Jenkins machine, and I will make it available on this machine. So what I do, I just do a new item. I say freestyle, and I say demo Docker Jenkins. I say okay, and there are very nice plugins for this, but I'm just doing it command shell because that's something I understand. So I'm going to be rootless here. I'm just saying, okay, any Docker instance which is running at this machine, I'm just going to stop it. And I'm going to clean the stuff up. And for this Redis, Java Redis thing, readme Jenkins, I first need to run this thing, and then I need to run this command. So what is this doing? The first command is making Redis run, and it's giving us this name, Redis, and then my Java application is being run, and it's linking locally to this Redis image I defined before. And the cool thing about this is that in my source code, I don't have to do name resolutions or whatever. I can just say here I'm referring to Redis, and it knows underwater that it needs to refer to this thing. So, like I said, this is all nice on a local machine, but this is not flying when you're talking about multiple machines, and that's why you need a container orchestration. But for the purpose of this demo, I will show you how this works and just say opslaan, which is save in Dutch. I'm starting the build. Of course, even here the demo gods are messing with me. I forgot to put the word Docker in front of it, so I put Docker, opslaan again. Oh, start. Let's see what's happening here. It's not auto refreshing. Okay, it says it's finished. So if I'm correct, I should have now on port 8080, I should have my wonderful demo app running now, and it's running. Okay. So this is all nice, but we want this application, of course, to run on orchestration framework, because we want to run it on multiple machines, and we don't even want to know which machine. We just want to know that this instance is running. So for this, in Azure, we have Azure Container Services, and if you look in the repository in GitHub, you see I'm using, for the ACS demo, I'm using this script. Please have a look at the script, because this script I'm using in this project to create myself a Docker or a Azure Container Service based on MESOS on Azure. So if I look in my portal, it's a parameterized job, so I need to give it some parameters. I will explain later on, and it will just call this shell script, and this shell script is just using an ARM template in order to create the Azure Container Service. Dashboard, create. So I'm creating it, built with parameters. I say I'm going to create it in West Europe. I'm giving it number 7, West Europe, Europe. Chris, I'm giving it 5 instances, WE7 bouwen, which means build. So this will take a couple of minutes. Let me pause this video for you guys, and I will resume when this step is done. We're a couple more minutes later, or quite a while, to be honest. But it's finished with building the Azure Container Service template. And so in my case, I've selected 5 machines, so it will have 5 agents. And it will, in my case, I only selected 1 master. So the end result of this will be when you look into your portal, you will see that I created this resource group, and this resource group contains of all these Azure resources. So at the end of the build, you will also see that I have here a public IP address, or a public hostname that it's been created based on the parameters I gave earlier, and I can access it with in order to do management on this, I need to set up a local tunnel. So I say -L port 80 on my side, port 80 on the remote side. So yes, and because it's port 80, it's lower than 1024. I need to have my sudo command here. Yes, we are trusting this guy, and I can even become root on this machine. So what I did now, I made a local tunnel, and I'm now able to access the master machine of the Azure Container Service template, of the MESOS landscape, on my local host, because I've tunneled it. And this is the main console. So here you can see that I have this landscape, and currently nothing is happening because I didn't deploy anything. You can see it's 6 nodes, it's 1 master and 5 agents. Here are the services, nothing running. Universe, this is a repository manager for MESOS, Marathon packages. Actually, Marathon is a packaging format which is older than Docker, but later on I will use these applications in my demo, so I will install them for now. Install. Okay, install, advanced installation, and I will say 3 instances, review and install. So what you will see immediately, if you go to the dashboard, stuff is going on, more memory is being used, and there's also localhost Marathon. Marathon is also installed, and with Marathon I can deploy my applications. So let's go back. So when I showed you my web application, you saw it was using Redis, and but I also need to set up a load balancer for this. And currently at the moment, so there is a load balancer on Azure level that does the load balancing on virtual machine level, but we also need a load balancer on the MESOS level to balance around Docker containers. And this load balancer is based around HA proxy. And when you go to my GitHub repository, you will see this script. And this script needs the resource group, which is linked to my account. When I go here, so this is the resource group I just created. So it will create a load balancer for this thing. So basically what this script does, have a look at it, but it contains of Azure CLI commands, which will just open up the network security group settings and the load balancer settings for this HA proxy, and it will deploy the HA proxy on Marathon. So if you have a look here at Marathon, you will see that the Marathon load balancer is being deployed. Let's see what happened here. Updating my load balancer agent. Oh, you see it's already deployed here. Okay. Let's wait for a minute. If I type in agent, I see here the public IP address of the agent. It's coming here. And the load balancer is being made available to this public IP address. So let's go here, 90 HA proxy. Let's see if it's already available. I don't think so, because it's still updating my load balancer. I'm going to pause this recording for a while till it's finished. So the script is finished now. My load balancer should be available. It is. You see, it's HA proxy. It's now available at port 9090, and with these parameters you can see some statistics. So now I would like to deploy my application onto the MESOS cluster. And with this I created also a script. It's in the GitHub repository. It's the 03 deploy app sh. If you have a look at it, you will see it takes a couple of parameters. Let's see how my JSON file looks. I'm going to copy it from the Java web app Redis demo Java web JSON. Copy it here. Okay. Okay. I'm going to deploy it. Deploy up. JSON up file is JSON web app Redis demo.json. Resource group name. Oh, it's out of my clipboard. Let's go back again. This is my resource group name. Of course, later on you want to have this all automated. The service port is the port number. I will make it available outside. I will make it available outside to 10,002. And the rule number, it's an eternal Azure thing. It's for the order of priorities of your firewall. It's a required parameter. You can make a smarter thing of that as well. So let's see if stuff is happening on Marathon. Not yet. It's still first doing on an Azure level. It's creating, opening, it's creating the load balancer rule, and then it's creating an open port on the firewall for this particular application, and it will open it on port 10,002 in this case. So I'm now finished with the deployment. So let's see if it's deployed on Marathon. Applications. You see the Java web app is running. I'm running Redis. So Redis is available through this name. So this name is actually made available through Zookeeper. And in this way, also the name of the application is available. And so in this way, other applications can know that this Redis container is available through this port, host name and port. So in the first demo I showed you with Docker Compose that the web application is linked with the -- link and the name, and it's all fine. But now we have a potential application which runs on multiple virtual hosts. So you need some kind of mechanism that can find it over several machines. And when you have a master node which contains the configuration of all the nodes, then you have a mechanism with Zookeeper to find where the container is available. So you see the web app Redis demo. It's running on the node with this IP address and the node with this IP address, and it's made available through the public IP address. And I showed you before. I showed you the HA proxy URL. And if you go to the HA proxy URL, you see that the application has been made available with the deployment script on port 10,002. So when I go to this address, 10,002, and I'm going to this one, you see this is the page being loaded, and you see it already contains 21 counters in Redis. You see the Docker name is also changing. That's being handled by the load balancer. You see? Okay. So the last step I'm going to show you guys is some tools for troubleshooting. In the beginning, when I installed MESOS, I showed you that I installed, let's see, localhost. I installed vscope. You see my CPU allocation has risen, my memory allocation has risen. I'm going to services. You see everything is peachy. On the node level as well. Here you can have a, here is something, the connection to the node is lost, but it's taking care of it itself. That's something you don't need to do usually. So let's go back to Marathon. These are all the applications. So now I'm going to localhost and I'm going to go to service and vscope. So vscope has a nice representation, graphical representation of your landscape. If you look here, system containers, let's see, those are all the system containers. Let's see, you can see processes, you can see the hosts. So for example, I'm clicking on this host, you can see all the information on this item as well. And what the really cool thing is, I can go inside a container with this tool by clicking on, let me see, yep. Application containers. I just want the application containers, and here I have my Java Web App Redis demo, and here I see on this instance I really like to enter the Docker instance itself, and here I'm in my Docker instance. You can see I started it with this command, and this is my configuration of JBoss standalone configuration. So this is the end of my hands-on demo. By closing it, I closed the terminal and I killed the Docker instance, so I shot myself in the foot. But that's okay, because I have this application running on multiple instances. So you will see probably now that it's self-healing itself, you see, unhealthy, and it's booting another instance up. So this is unintentionally, but it's good to see what's happening on the water. So thank you for watching, and hope you liked it. Have a nice day.